Okay, now let's run the forward selection, backward elimination, and stepwise regressions, and we have the independent variables already assembled when we did the last VIF. We have already done that. So the data is right here. The unleaded starting from period number 2, and then lagged by 1 the unleaded price, lagged by 1 the crude oil price, lagged by 1 unemployment, lagged by 1 S&P 500, lagged by 1 housing, and lagged by 1 time. Well, time is just not, sorry, take that back. Time is just time. There is no lag there. Okay, so this is our dependent variable, and these are our possible independent variables. There are 6 of them. We're calling them Z1 through Z6. So now we need to run the forward selection, backward elimination, and stepwise. And in software packages that are dedicated to statistical analysis, these will be available as part of the package. But in Excel, I have written a macro for that, and it's available along with this file. So here I have provided a clickable button. So if you click this button, then you will be able to run the stepwise regression. Okay. But for this stepwise regression to work, you have to enable content when you open the file. If you did not do that, then this stepwise regression will not work. Okay. So let's click run stepwise. Okay, that opens up this dialog box. So it looks like a regression analysis dialog box. So you have the input Y range. So we already have set that up right here. So this is our, and we're going to include the label. So up to the estimation sample. Okay, and input X range. So we input all the possible X's we have at this stage. Okay, so which is starting from there up to that. Okay, now we have label in the first row. Okay, let's do the output cell. Okay, I've already provided output cell area. So here we will use that one for the forward selection, that for backward elimination, and there is one other for stepwise. Okay, so now we're doing forward selection, and here is where you have the threshold for alpha to enter. So you can set 5% threshold, which means it will bring in variables as long as the p-value of the variables that comes in is less than or equal to 5%. That is, the variable is significant. Once you hit a value that is greater than 5%, so we will do 0.05. You should write that as you should enter as 0.05. Then the process will stop. Okay. All right. So now click OK. So here, this is your Y, and these are the independent variables. There are 6 of them. Okay. So it brought in the first variable Z1. You see the partial p-value is 0, close to 0. It's not exactly 0. And it gives you the R-squared value and the model standard error. Now with Z1 already in, the next step is brings in Z2. Okay, and the partial F is given, and the p-value is given also. So now the R-squared has improved, maybe not very much, but the standard error has gone down by a little bit. And then with Z sub 1, Z sub 2 already in, the next variable it brings in is Z sub 5, and once again the p-value is close to 0. Then the next variable to bring in is Z sub 3, and after that it stops. So which means once these 4 variables are already in, the next best variable that it is able to bring in has a p-value greater than 5%. So it stops at this point. So the best model that we are able to identify with forward selection is a model containing these 4 independent variables. Okay. Now we can run backward elimination. Okay, again, go back and click the button, and here what we need to change is the output. Okay, the output range is that. Okay, and we have to select the method. Instead of forward selection, you use backward selection, and again we're going to use 5%, which can be somewhat different. So this means you start with all the 6 variables in, and then you toss out variables just as long as the partial p-value for the variables that you toss out are greater than 5%. Once you hit 5%, then you'll stop and you'll keep the variables that are still in the model. So click OK. So now you see you start with all 6 of them. Okay. And then the variable that is removed first is Z6, and it has a partial p-value of 21%. Okay. And then the next one to be tossed out is 4. And that has a partial p-value of 46%. So now we are left with Z sub 1, Z sub 2, Z sub 3, and Z sub 5. So that's your best model in backward elimination, because the next step, the variable that gets selected apparently had a partial p-value less than 5%. So it so happens here, the forward and the backward, they both give you the same model. So here is where our initial pruning of the number of variables using multicollinearity helped us with both backward elimination and forward elimination coming up with the same answer. Your textbook did not do that. So they start with all the 8 variables in, and the backward elimination gives you a different model, and that opens up a different can of worms, which we are able to avoid by doing the initial pruning. Okay. Now let's do the last one, which is the stepwise. Okay, click again, and everything remains the same except 2 things. The stepwise output range, you should change that to V7, and stepwise you have to enter both alpha to bring in and alpha to toss out. So these 2 alphas can be different, but I'm going to use 5% for both of them. And see, you bring in Z1, and then you're not throwing anything out, Z2. Then we try to throw one of them out, and apparently that was not successful, so we did not throw out anything. So Z5 comes in, and then finally Z3 comes in. So stepwise also gives you the same model as the previous 2 cases. Okay. Now finally we can do a best all sizes, okay, the all subset model. Okay, again go back to stepwise regression model building. Now change this to output cell to that. Okay, so now go back to forward selection and you enter a very high value, say like probability 1, so which means the process will not stop until all the variables are in. So that way you will have a model of each size, 1 independent variable, 2 independent variables, 3, 4, 5, and 6, so all the way down instead of stopping somewhere in between. So click OK. Then here you see 1 by 1, 3 variable model, 4 variable model, 5, and 6. Okay. Now of course this is usually we don't need to do this. What we need is the best subset model only, best model from the 6. So what we now have is Z1, Z2, Z3, and Z5. So that's the model that we have identified. So let's go ahead and assemble this right here. We will do that in the next video.